I'm going to present some new results from my laboratory that show air quality may affect your ME/CFS and fibromyalgia, fatigue, and pain. So this is going to be a sneak preview of results that are being sent out now for peer review and for ultimate publication. I'm going to present it here briefly, or at least a part of it, before we send it out. So I'm Dr. Younger. I'm director of the Neuroinflammation, Pain, and Fatigue Laboratory, and we're trying to figure out myalgic encephalomyelitis, chronic fatigue syndrome, fibromyalgia, gulf illness, long COVID, and similar conditions. So this study I'm going to talk about today was run by three of my students, Chloe Jones, Olivia Haskin, and Gregory Lashley. And again, it's about, does the weather patterns and do pollutants in the air affect the severity of your pain and fatigue? Now, we've already known for a really long time that poor air quality is a significant health risk. That's why we have HEPA filters in our central air. It's why if you live in certain parts of the United States, you will occasionally be told to stay in your house and not come outside because there's a forest fire and the smoke is at a level that's actually dangerous to your health. And so when air quality gets so bad, it's a risk even to perfectly healthy individuals. And we also know that lower levels of poor air quality, so less severe air quality problems, can affect people who are particularly sensitive to it, even if you don't have a respiratory problem. So of course it's going to affect people with asthma or people with some kind of lung disease, but there are people who have other kind of conditions that can also be affected by poor air quality. Rheumatoid arthritis, sickle cell anemia, and some other chronic inflammatory autoimmune disorders can be affected by air quality. But to my knowledge, no one has ever studied whether air quality and weather affect ME/CFS. And so that's what this study was intended to do. So basically what we did is we took an existing study where I look at cytokines. We'll talk about that another time. And I said, well, we're already collecting their symptoms every day. So why don't we look at the weather? Because we can pull that information from national databases that track weather pollution every day. So what happened is these are ME/CFS individuals, and they have a little device, or they use their phone, where they can track their symptom severity every day for long periods of time. So they can rate their fatigue severity, their pain severity, their cognitive issues, how much they're able to do that day, and other variables. And so I want to show you a picture here. What we can do with that is then plot over time how their symptom severity fluctuates. Most people with ME/CFS have some degree of fluctuation from day to day. And so while most of their days are going to be bad, some days are going to be worse than others. And then the question is, why? What's making some days worse than other days? If we can figure that out, we may be able to find targets for new treatments. And so we're looking for something like this, where there's some other variable that tracks with the ups and downs of the symptom severity. Say, for example, if it's just fatigue. So we can have really bad fatigue days, really good fatigue days, or I guess relatively good fatigue days. What's deciding that? There's got to be some variable that's controlling those good and bad days. So as I said, we took, and by the way, this picture I'm showing you right now, these are actual data. This is a real person, but it's just a couple weeks I pulled out. There's nothing special about this particular set of data. I just pulled it out as an example because this individual shows considerable fluctuation. So it just illustrates my point. So we would take these daily data, way more than 2 weeks. Most people would provide data for almost 3 months, daily data. And then we can take historical climate and pollution data from the National Oceanic and Atmospheric Administration. And then we can take air quality information from the EPA, or Environmental Protection Agency. And because these people were all living around the Birmingham, Alabama area, we can take that information from those sensors from the government weather associations and link up that information with the self-reported symptom severity. Now, we have access to a high number of weather variables. So there's course, temperature, there's humidity, there's air pressure, there's carbon dioxide. But what I'm going to focus on today is air quality and pollution. It would be too complicated to go over other variables. So we'll just keep it focused on basically air quality. So particulate pollution are the small things that are in the air that can affect your health. I'm going to use this little screenshot from the EPA, and it shows the different levels or the different sizes of these pollutants. So we usually categorize these. There's particulate matter 10, 2.5, or 1, and this is the size in microns. So 10 is the larger pollutants, things like maybe construction site dust that you can actually see. 2.5 or smaller, these are things where diesel particles, combustion type particulate matter is found. And then at PM1, things are even smaller. There are a number of things that can get this small, but this is where we start to think about viruses and bacteria that are especially small. Now, HEPA filters are aimed at 0.3 microns, I believe. So they should capture most pollutants, and that's what they're designed to do, to remove like 99 point something percent of pollutants that size or bigger. So they capture most of the things we're going to talk about as long as they're functioning properly. But there are some things that are smaller than 0.3 microns, and the HEPA filter can't effectively filter those out. And again, those are really tiny things, like some viruses are that small, some bacterium are that small, and there are a few other things. But generally, we're talking about things that are 2.5 microns and larger. Those are the things we're targeting. I think there's more appreciation about how the smaller particles may be causing problems because they can get even deeper because they're smaller. They can access more parts of our lungs, but that's under investigation. So anyway, let me show you a map. This is a US map, and this is looking at the 2.5 micron pollutants. This is an example of an air quality type of map you could get to see if there are places where there's an extreme risk of having your lungs being assaulted by things in the air. Now, this particular map is from purpleair.com, and there are other places you can get this. There's government sources as well. Purple Air is a commercial group. I'm not supporting them. I haven't used them. I'm just noting that they're a commercial group that uses monitors that you can buy, put in your house, and then that data gets uploaded to their servers, and then they have maps across the entire world where they can monitor trends in pollutant levels. So they're aggregating all these data from the individual sensors that have been bought by people. So again, this is the US EPA 2.5 micron particulate matter map, and you can see pretty clearly, by the way, I didn't say this, but green is good, and as you get into the reds and purples, that is severe. So you want green. There are some areas with great air quality. Colorado being a good example, at least right now it is. I think it's something that place is famous for, but anyway, this is up-to-date information. We can see that the air quality is great in that state right now. Now, there are other problems. I'm not going to call out anyone in particular right now, but you can see that there's areas where the air quality is not looking too good right now. There are some that are kind of in the middle, and then there's some that have extreme issues. It could be due to congestion pollution. It could be due to forest fires. Sometimes it's just unfortunate geography, just how the weather gets trapped in certain areas. People, groups that are in close to the ocean may have advantages because of the wind that's washing in over the ocean. So geography is important as well. That's something to consider. So that's the pollutants and the particulate matter. Again, 10 micron, 2.5 micron, or 1 micron. There's also another index I want to mention, which is called the Air Quality Index, or the AQI, and that's released by, again, the United States Environmental Protection Agency. That's where you get a lot of this information. And the Air Quality Index is color-coded based on the health risk. It's very similar to how we just saw the particulate matter. So green means the air is good for everyone. Yellow means it's good for pretty much everyone. If you are very sensitive, you might have a problem. If you have really bad lung disorders, really bad asthma, you might be sensitive to it, but generally we'd consider it fair to good air quality. Most people don't have to worry about air quality when it's yellow. Orange is a level where, you start thinking it could be causing problems, but mostly with people, again, with asthma and other lung disorders. So orange is not considered a health risk for healthy individuals. Now, when you get into red and beyond, this is where it starts to become a health risk for everyone, including individuals who are healthy. So if you weren't familiar with that system, that's used throughout the United States, and this is how it is used. So this is what we looked at. We looked at the micron pollutants, and we looked at the air quality index in ME/CFS. And what we wanted to know is, on days when the air quality was worse, was the pain and or fatigue worse on those days? So we had 58 women with ME/CFS. These data were collected before COVID-19, so that doesn't affect anything that we see here. The women gave reports, or the participants gave reports for an average of about 62 consecutive days. So we have around a couple of months of daily severity reports, and then we would get the atmospheric climate data for those same days for each of the participants. So if you do the math, that yields about 3,500 paired samples, which is a lot of data. So we have a lot of power for the statistics. So it wasn't a lot of people, but because they were doing this study longitudinally, we got a ton of data to work with. Now, we're only looking at self-report pain and fatigue. There are other variables we could look at, and we'll probably do that in the future. But for right now, we just picked those two to start. This is just kind of a preliminary look at the idea. So fatigue severity from 0 to 100 and widespread pain. The reason we did pain is because a lot of these individuals meet criteria for fibromyalgia in addition to ME/CFS. So we did want to look at pain. There's quite a few findings on weather, but again, I'm only focusing on the two kind of air quality things. When we get the paper accepted, I'll probably go into the other variables in more detail. So let me give you the bottom line. I'm going to put up the statistic for you. So we found that in ME/CFS, fatigue severity was positively correlated with particulate matter 10 microns. And that was statistically significant. And so on days where there was more of the PM10 level of pollutants in the air, people with ME/CFS were reporting greater fatigue. So that's finding number one. That's what we would hypothesize here. And the second finding was with the pain variable. We found that the pain variable was positively correlated with the air quality index. Remember, the higher the number of the air quality index is actually worse. So on days where the air quality was worse, the pain was also worse. And this was a very strong, statistically significant relationship. So what we can say is that fatigue and pain in ME/CFS is worse on days when the air quality is worse. Now, that may be something you've already guessed, or that may be something you already know, but again, I've never seen this in a scientific study, and so we had to run it to see if it's actually true. Now, I was surprised that we found anything to be statistically significant. It's not because I don't believe the relationship. I think it makes a lot of sense. The reason why I thought we wouldn't find anything, a couple of reasons. One is that we only looked at air quality for a few months, and it was in an area here in Alabama that doesn't have huge variations. We don't have generally huge spikes in air quality issues. And so we never were able to test severe air quality problems. And so we were looking at relatively minor fluctuations. And so I wasn't expecting to see much because the variations in air quality were so small. But it turns out that even these small variations in air quality seem to be enough to change the experience of those with ME/CFS. The second reason I wasn't really expecting to find something is because we didn't assess the microclimate, which is going to be more important than the microclimate. Like I said, we only took data from the airport and the sensors that are located there to be a proxy for everything happening in the general area. But of course, what's more important is what is each participant sitting around in every day. I know the overall climate is part of that, but what's more important is, well, is there a construction site across the road? That's going to have much more influence on their health than the general climate. What's going on in their house? If you're spending most of your time inside your house, the climate inside your house and the pollutants inside your house are going to be more important than what's happening outside. And we didn't measure that in the study because, again, this wasn't a weather study. This was kind of an add-on thing. So there are a lot of things we didn't collect. So I hypothesized that if we actually did a proper study between weather, pollutants, and ME/CFS, and we actually put the monitors in each person's house, we would find much stronger results. Now, that's my hypothesis. I think it makes sense, but we'd have to do that to see if that's actually true. I do think that these initial results are powerful enough to warrant doing a proper study with proper monitoring equipment. I don't think it would be that expensive. We would need pretty good air monitors. I would like to do people across the entire world, hit all the continents, most of the countries, so we could test all kinds of different levels of pollutants and all kinds of different climates. We would track whether people are spending a lot of time inside or outside. If they're outside, we could take their local climate data to add on to their monitor data. And so there's just lots of ways where we could actually know with much greater confidence what the person's actually breathing in throughout the day, much more precisely than what we did in the study I'm presenting now. So it'd be really cool to track maybe 1,000 people, send the monitors, track their symptoms, and all these variables, and then we could more conclusively know how much weather and how much pollutants contribute to MECF severity. Now, why is this happening? I don't know. I haven't studied it yet, although I do have the data to do so. I just haven't gotten to it yet. As you can tell, if you track my talks every week, we've got a lot of stuff going on simultaneously. So, we can't be pushing ahead on everything at the same time, but I will get to it. My guess as to what's happening is with individuals with ME/CFS, these particulates that are being pulled into the lungs are triggering an inflammatory response that's turning into a systemic inflammatory response. And I think that's causing the exacerbation of fatigue and pain. Now, we'll test that later. The way I'll test that is I actually have a lot of blood draws on these people as well, so I can figure out if their inflammatory markers are higher on the days that have more or worse air quality, I guess is the best way to say it. So we can look at C-reactive protein, we can look at interleukin-6, and we'll find out if that's the case. That would be my hypothesis. Would be really interesting to show that. I don't think anyone's really ever done that before. So we'll definitely tackle that and see what happens. So what to do now based on this data? First of all, let me say again, these results are preliminary. It hasn't even been peer reviewed yet. They may find something I haven't thought of. So we'll talk about that again in the future when the paper is ready to be published. But based on what I've seen so far, this supports what you've been told anyway. If you're using central air and you have a HEPA filter, you may want to check that HEPA filter and make sure it's not 3 years old and a complete solid brick of accumulated pollutants. That happens. I'm sure. I wonder what the general state of most HEPA filters are. Make sure it's working. Of course, it's not going to work if it's all clogged up. You can consider getting an at-home air quality monitor. Unfortunately, I can't recommend a particular one because I can't recommend something unless I've used it in a study, and I have not done that so far. Now, I've looked into it, and I've seen devices that look like they would do the job. Some of them in the low hundreds, like maybe 200 or so. But I have to have them in my hand, and I have to be able to use it, and I have to test the data before I can recommend it. So you'll have to find another source. But in general, I like the idea of getting an air quality monitor to use in the places where you spend a lot of time and making sure that the pollutant levels are low. Now, the warnings with that are, I don't think any monitor that you can buy is going to capture everything. And I fear that many devices, especially the ones that are cheaper, are probably exaggerating their sensitivity and accuracy quite a bit. And so do be careful with that. Having a professional inspection of your house can cost thousands of dollars. And that's because there's so many tests that they have to run to capture everything. Just looking for mold and mold spores, just that one thing, that can cost $250 to $500 depending on the size of your house. So it can be very expensive to make sure that the air quality is good in the place where you live. So anyway, the air quality, I guess the bottom line is we're finding relationships. There does seem to be a reason why we need to look at air quality because it seems to be contributing to ME/CFS severity. I don't think it's causing ME/CFS severity, but it does seem to be making it worse. Now, I want to do another study before I actually say how much worse it's making, but we can see right here that there's some relationship between the two in terms of severity. So it's something to consider if you haven't already considered. We do have to do more research, but I think it's definitely worth looking at more. So that's the sneak preview. Again, just a couple statistics. It's something interesting. I think it needs a new study designed specifically for answering those questions about climate and air pollution. But I'm glad that we were able to at least take an initial kind of peek at that question using data that we had already collected. So I hope that's useful. And I will be back, of course, next week with more data and more results. I'll see you.